Okay, welcome everyone. We're going to start the class in about like 2-3 minutes. We'll just wait for some people to join in so that we have a full quorum and then we'll continue. Okay. All right, I think that's enough wait time, so we'll start now. Okay. So today, before we start, I just want to state some rules. We discussed that last time, that please keep the questions related to the topic we are studying today. So our topic, I will explain what topic we are studying so that you know what type of questions you need to ask. The reason for that is that people are using the chat for a lot of questions during the lecture or the session. And there are a lot of beginners that haven't yet covered those things. They are just starting off with their networking journey. So they get confused. Please keep the questions. You can use the chat while the session is going on to talk to each other or throw the questions, but I cannot focus on the chat. So if you're throwing a question at me in the chat, I'm probably not looking at it. You guys can talk to each other. I will give you enough time at the end of the lecture so that you can ask me those questions, or I'll try to go through the chat and see if I can catch those questions as well. And I'll be answering them. So you will get ample amount of time to ask your questions. Don't worry about that. You can ask questions after the class as well. So you can use the group chat. If you're part of the exclusive group that we have, then you can use that group. And so this is just a little cleanup that we have to do, because last time a lot of students were getting confused, like they don't know if they need to focus on the chat, because a lot of people are talking about a lot of things in the chat, and there is a session going on and they cannot catch up. Okay. So today we are starting off with the basic switch and end device configuration module 2, which means we are directly jumping into configuring the devices. Last time we talked about a lot of things, what the networks are, what are the end hosts, what are the intermediate devices, what are the physical media. So today we are jumping in right into the intermediate devices, where we talked about switches, firewalls, routers, wireless routers, or access points. So now let's get into one of those intermediate devices, because as a network engineer, that's where you are going to work on. You are going to work on intermediate devices like router, switches, access points. Okay. So today we are going to talk about Cisco iOS access. How do we access the Cisco iOS, which is the operating system running on the Cisco networking devices? How do we navigate that operating system? What is the command structure? What are the basic configuration that you have to do once you get into it for the first time? How do you manage those things? How do you save configuration? What are ports? What are addresses? How do you configure addresses and verify connectivity? So I'm going to do this from very scratch. So there is, I'm not assuming that anyone knows anything about CCNA, anything about networking or devices. So we'll try to take baby steps today. Okay. All right. So first of all, what is an operating system? You all are familiar with the operating system because you are working with your laptops, with your mobile phones. All of these hardwares that you are holding in your hands have a special software that is called an operating system. So an operating system has multiple layers that we so an example of an operating system is the Android operating system that you're using on your Android mobile phones, or iOS. The Apple phone uses iOS with a small I. You are using Windows 10 or Windows 11 or Ubuntu or Red Hat. These are all operating systems. The operating system itself consists of two parts particularly. So all the hardware, let's say I make a hardware, like let's say this is a switch with 4-port switch. It could be, you can think of it as the wireless access point that you have, or a wireless router that you have at your home, which is giving you internet access right now. Or you are a computer, somebody is sitting in here on the computer and they're interacting with your computer using Windows 11 or Windows 10. So on their computer, they have a hardware. Let's say this is a CPU or this switch. So somebody's asking about some quizzes, it doesn't matter. We can sort those things out after lecture. So if you have missed a quiz, it doesn't matter. You can do it later on. All right. So on this CPU, you have a hardware. Inside the hardware, what things you have? You have physical components of this computer, this machine that you have, in which some important hardware is a CPU, a processor, or a RAM, or a hard disk on it. So these are all hardware components that creates a computer or a machine or a mobile phone, or in a similar way, a switch or a router. So a switch or a router is nothing different than a computer. It is almost same as a computer with very small differences. It also has a processor, it also has RAM. It doesn't have a hard disk usually, but instead of a hard disk, it has NVRAM or flash memory, which acts like a hard disk. It doesn't need a SSD or HDD hard drives because it doesn't need to store a lot of data. It just needs to store small files like configuration files or the iOS, the operating system that it needs to boot up in the beginning to run on this hardware. Okay. So a switch or a router, you can think of it as your computer or your mobile phone with the hardware components, like a CPU, RAM, and some kind of a small storage media, which we call a flash memory and NVRAM. To run this hardware, to make it work, you have an operating system which consists of two parts to run this hardware. One part is called kernel, which is the specific part of a software that handles the communications between the hardware and software of a computer. It is basically a software that manages all this hardware, the hardware ports of this switch or a computer. It manages your CPU, it manages your RAM, it manages your hard disk. It gives you all the control that you get when you are working with your computer. Then on top of that kernel, you have a special program that is called shell. That is actually the software that gives you an interface to interact with kernel so that you can interact with hardware through the kernel. The shell is the user interface that allows user to request specific tasks from the computer. So these requests can be made either through the CLI or graphical user interface. So the shell is your interface with a human. So when I'm working with my window machine, like here, whatever graphics that I'm seeing, the pointer I am moving around, that is part of the shell. Or if I open up a terminal, that is also part of a shell. So there could be multiple types of shell. So one shell is this CLI. This is what we call command line interface, where I can run command. So my Windows operating system also have this CLI interface through which I can interact with my computer. For example, with dir commands, I can interact with my computer to tell me what files are saved on my physical hard disk. I cannot talk to hard disk directly. I have to talk to my hard disk to show me what files are saved on it through this command line interface. So this command line interface is the shell through which I can interact with the computer. Similarly, I can also interact with my computer and ask my hard disk how many files or which files you have using a graphical user interface, which is this one. So I can see what is saved where, how many folders, what files, and I can run it from here. Similarly, I can run it from command line as well. I can run calculator, let's say, by giving it calculator command. So if I give it that command and hit enter, it will open up a calculator here. So there are two methods to interact with my devices, okay? Now, we talked about the graphical interface. So the graphical interface I showed you, so I hope that should be easy. There are a lot of different graphical user interfaces, like our computer or on the Windows machine, you have the Windows 11 graphical interface. Other operating systems have their own graphical interface. Your mobile phone, Android, has its own graphical interface. You can interact using your thumbs or touch screen. Linux has its own Mac operating system. Apple has its own. It's called Mac OS graphical interface. Linux has KDE. Apple phones has iOS, and Android has an Android operating system. The problem with the graphical interfaces is that they are complicated, and they're useful for our daily tasks that we need on our mobile phones and computers, but they do fail a lot. They fail, they crash. There are other reasons that we would want to avoid using graphical interfaces because it gets very complicated. There's a lot of code that needs to be run and managed. It needs a lot of RAM to load up graphical user interface and show you a beautiful screen. Obviously, you also need a screen to look at these graphics and so forth. So in technical environments where you don't need a polished interface to work with because it's not meant for general people to work with it, you would want to avoid a graphical interface because the CLI, the command line interface, is much cleaner, simpler, easy to manage, and it has a very small code. So it can run on a very little amount of RAM. So it's not using up a lot of RAM. That's why when you come to the networking devices, they typically don't have a graphical interface. Okay? They don't have a graphical interface. No graphical interface for Cisco iOS. So Cisco iOS, just like you have other operating system like Mac OS or Windows 11, Linux KDE, when Cisco makes hardware like network devices for switches and routers, the operating system Cisco installs is called Cisco iOS, Cisco Internet Working Operating System. That's what comes pre-installed on those devices. And to work with them, to log into these devices, you don't have usually a graphical interface. You usually just have a command line interface to interact with, which would look exactly like this command line interface that you have in Windows 11. So you can interact or configure your switches and routers using a command line interface only in most cases, which is changing a bit in some cases now. You can have web graphical interfaces and you can go to a website and provide an IP address of the switch or router, and you can get a web page through which you can configure it, but that will always be very limited. You still would, in many cases, want to access the CLI to configure these switches, okay? So we talked about on operating systems. So now that we have established that we have on Cisco devices, Cisco iOS is running, it has only command line interfaces. And the question is, how do you access that CLI? Because when you look at a switch, it has just some ports and it has one power cable that you plug into power plug and it switches on. It might have a router usually have a switch, doesn't have an on and off button even. So, but there's nothing to connect a screen to it. Like you cannot connect a monitor to it. You cannot connect a keyboard or a mouse to it. There are no ports for it to do that. You cannot do that. There are only RJ45 ports usually, or sometimes mini USB ports to which you can connect. But you cannot connect a keyboard or mouse usually to those mini USB ports either. So the question is, how do you access a switch, or how do you access the command line interface on these switches or routers or wireless access points? Well, so usually all of these devices would have a special port that is called console, and it's written on it. And we are going to look at it in a packet tracer in a few moments. So that's a physical management port used to access a device in order to provide maintenance, such as performing the initial configuration. So usually the first time when you buy a switch or a router, you get it out of a box, the first you need to do something called initial configurations before you put it in a production or anything. You need to first have basic configuration, and to do that you first need to access that switch or a router using a console port. That is a special port, a physical port on the device whose only purpose is to access this device using a computer. So you must have a computer or a laptop. You cannot attach a mouse, keyboard, or monitors to it. You must have a separate computer or a laptop, and you connect to it to its console port. Now, how do you connect to the console port? You need a special kind of a cable that is called a console cable. So in older days, we had this kind of a cable whose one end is called RS2 232, and other end is just RJ45 normal port, the Ethernet cable port. So this end, the RS232, goes into a computer, where computer had these RS232 ports commonly available in older computers. So that's how you would connect to the console. So this end would go to the computer, and this end would go to the console port on a switch or a router. And then you would need a software that is called a terminal software. In our case, these days we use a software called PuTTY or PuTTY. Some would say PuTTY, some would say PuTTY. This is how it's pronounced. And this is where you would say that you want to connect to this device. So over here, you would select serial port, and it would say COM1, and there's a speed to which we would go through these things. What are these things? And then you would click open, and it would get connected to it. So PuTTY is one type of a software. There's a Teraterm, another type of software, through which then you would get this terminal-like access to the switch, through which now you can enter commands and configure these switches and routers. That is one way initially you would connect to a switch or a router. After you have configured it, when it's working in production, it's connected and it's passing on traffic and data from one device to another device, connecting multiple devices, then you can configure something called secure shell or SSH or a telnet. So telnet was the older method. So you can configure these telnet, and SSH is the safer method. Telnet is an old method that we don't want to use anymore, but we will see how we can configure both of these. And then after that, once these are configured, then you can access these devices to configure them or monitor them without needing a console port. So console port is only for initial configuration. You need a physical cable to do that, and a computer through which you would connect to it and get PuTTY software through which you would connect it, and you would get this terminal-like access to the switch where you can run the commands to configure it. But that's just for the first time. After that, when you first connect to it using the console method, you would configure SSH or telnet on these devices, and then you can disconnect this cable. You don't need this cable. You don't need the console port. After that, we can access them using telnet or SSH protocol just from our own terminal using SSH or telnet commands. We will look into that later. There's a whole chapter on that, how we would do that. Today, we are just going to focus on the console method and the basics, okay? So we talked about PuTTY or Teraterm. These are the software that you can use to connect using the console method. Okay, so I don't want to spend a lot of time on the slides, so because we want to jump right into how we can configure once we access it. So we'll just jump into the Cisco Packet Tracer and start working on the physical stuff. Well, it's not physical. Packet Tracer is a simulation tool. So a little bit about Packet Tracer. Again, we talked about it last time, but let's talk about it again. Packet Tracer is a simulation tool where we can simulate real-life networking devices in different ways, in a logical topology, in a physical topology. We can do simulations. We can slow down packets. We can open packets and see what's inside them step by step, when it's sending, when it's receiving, and so on. But the important point to remember about the Packet Tracer is that it's just a software. It is just giving you an illusion that there's a software and you're running commands and it's doing this and that. But in reality, it's not doing anything. It's doing nothing. It's just a graphical interface showing you, when you run this command, this is what you are supposedly see on a real hardware. But it's very accurate. So you can practice your entire CCNA exam topics inside Packet Tracer. But you have to remember that this is not the real thing. This is just for you to get an understanding. Because in these devices, when we pick up a device like a router or a switch, let me pick up a switch. So this is a switch. I can click on it. I can get the CLI commands, and then I can run. It gives you an exact feel as if you have accessed the switch via a terminal using a console port. And then you went into a PuTTY, hit enter, and you got this access in a terminal. And now you can just run commands. Show clock is a command. So this is the time that is configured on the device. but there is no command that you're running. It's just a software giving an illusion that when you do this on a real device, it is supposed to give you this output. It's just giving you that feel. We have a method to download the Cisco iOS that runs on the real hardware and also practice with that in our computers. That's where the CML, Cisco Modeling Lab, or EVNG comes in. That's where the difference between a packet tracer and a CML and EVNG is. Packet tracer is a simulator. It is simulating, just giving you a feel of how things would look like. The real thing is not there. CML and EVNG are emulators, essentially. Emulators means you get the real operating system code from the Cisco devices or download it from a Cisco and put that in CML and EVNG and then run it. And then you're actually using the exact code that is running on the hardware, exact Cisco iOS, the Internet Working Operating System that runs on the hardware is running inside CML or EVNG. And then when you're running the commands and getting an output, that is the real output that the hardware device would show you. And that's exactly how it would behave, okay? So we are going to do CML and EVNG as well, but the most of time we are going to focus on the packet tracer. Reason being, in packet tracer, we have a lot of options for beginners to get a good understanding of how networking devices work, okay? So let me just delete this switch for now. And let's focus on physical topology because this is our first time. So over here, I'm clicking on physical. This gives me a whole world view. So this is my home city. Inside home city, I have in a corporate office. I can create multiple offices here and connect them. So you can do a lot of simulations like real world simulation here. And then inside a corporate office, you can see like this is an office. There are different offices in rooms. And in one of the offices, let's say that's a data center where we have a wiring closet. So let's get inside. Let's see what's inside it. Well, inside it, we just have one rack. Let me actually delete that rack. So let's say we don't have anything in here and we want to do some networking here for you guys. So over top, I can hover over these icons and I can see there's a create a new rack. So I can click on it and I have a rack. What is a rack? Rack is well, this is a rack that you can see. It has a specific standard sizes. This is called rack. So in the data centers, anywhere where you need to put networking devices, servers, switches, routers, anything, you need a rack to properly manage it. It has cable management system, it has power management system, it has a standard size where all the switches, routers, and servers can fit easily on top of each other, giving them proper space so they don't heat up, so on and so forth. So whenever you hear about a data center or servers or switches, they're not just laying on a table somewhere. They're always fixed inside a rack. So you need a rack first. So we add a rack. I also need a table. So I add a table here where I would be putting stuff. I can also add a shelf, just like a storeroom. So at the bottom, I have routers. So if I click on a router here at the bottom left in a packet tracer, I have different versions of routers I have. So let me take a 4331. 4331 is a model of a router. I can just drag it and put it on a rack. I can just drag it and put it somewhere else as well. So let's say I can put it on a table. I can put it on a shelf, but it's powered off. So placing a store, so please power it off before sharing. So we can power it off. Let me zoom in on it. So you can zoom in and you can right click, inspect the front. I don't see a power on off button. I can inspect the rear and I can see that it has an on and off button. I can switch off. So this is how a router looks like in real life. Okay. In real life, if you purchase a router model 4331, this is how it would look. This is the front side. Then you can inspect the rear. This is how it look from the back side. What does it have? It has a Cisco. It says Cisco 4300 series. It has some status lights. There's a power cable connected to it. It has an on and off button, and there are some bunch of ports where you can fix the RJ45 cables. So we're going to look into it, like what are these things, okay? Similarly, if I click on switch here, and I can bring a 2960 switch here and put it on the top of router, which is not a good idea to do, but we can do, just like in a physical world, we can do it here as well. And you can inspect the front, which looks like this. It looks like it has a 24 ports where we can connect RJ45 cables. That's how it would communicate or connect other computers. And then if we right click on it, it doesn't give me, well, it does give me, let me close this. If I right click on it and inspect rear side, it just has one power cable connected to it. Switches usually don't have even the power on off button. And you can see here, it says console here. Let me just magnify it a bit so you can see it better. So I think you can see. So this is a switch on the rear side. It has a very special port that says console. I think my screen share went away. Give me a second. Share this screen. Okay. And back to here. All right. So you can see this is a special port that says console on top of it. This is where we would be connecting our computers to get access to this switch, okay? So we'll get to there in a while. So before we do anything with that, I just want to follow the slides and let's see what we can do over there. All right. All right. So can you give me, somebody can send me a message in a chat that you can see my screen now? Yes. Okay. Thank you. All right. So before we connect to it, Packet Tracer gives us an easy way to start working on it because Packet Tracer has many shortcuts, but in real life, you wouldn't have these shortcuts. So, okay. So for example, let me delete this one. So let me delete this and I go back and click on a switch. I put on a switch 2960 over here. I'm in a logical mode, not in a physical mode, okay? So if I click on switch, it has a CLI tab, which gives me access directly to the switch where I can just start running commands. Now, this is something you cannot do in your real life. There's no way that you can bring up a switch and just somehow magically start running command. You have to access it through the console for the first time. Let me, I think my screen is back on the other screen, so let me share that screen again. That was better. Okay. All right. So we are back on the switch here. That's fine. It's just the headline. Of course, this is a live class. Akin, how are we talking if it's not a live class? You're not watching a recording, Akin. All right. Okay. So, all right. So let's start by doing some basic commands and understand how we can interact with a switch or a router. So when you access it and how we are going to access it using a console port, that we are coming to that in a bit. But before that, let's just do some basic commands, okay? So let me put that on the top. All right. So when you first time access it, the device gives you a prompt. So this says switch, this is the default name on the switch, and it has this little arrow that's the prompt. This is what we call prompt, where you can start just typing and give it a commands. You can hit enter as many times as you want just to clean the screen. So for example, I do show clock and gives me some output. I ran a command. I can just keep hitting enter to just get rid of that so that my screen is clean. So you would see network engineers doing that a lot. They just keep hitting enter And the purpose for that is to keep the screen clean so that they can focus on what they are working on. No display. Who is saying no display? What do you mean? You can't see the screen? You cannot see my screen share? Well, Maxine is saying that he can see the screen. Let me just stop the screen share and start it again. Okay, Omar is saying he can see, other people are seeing it. So if you're not, somebody cannot see a screen, so I don't know, something on your side, but I will still just stop the screen and share it again so that if somebody's stuck, it gets fixed for them. I'm stopping the screen, sharing it again. Hope that fixed it for you. Okay, he's good now. All right, happens sometime. All right, so for the first time when you log into the switch or router using the console port, it gives you a prompt, and there are multiple modes inside the switch and a router which indicates what you can do on the switch at this time. So when you have this little arrow sign, this is the name of the device, which we can change. And this is an arrow sign. So when you see an arrow sign, that means you are in the user exec mode. That's a special mode. When you first time log into the device, you are by default in a user exec mode. It allows you to access only limited number of basic monitoring commands. You cannot do much in this mode. It is identified by this prompt that ends with this icon. So whenever you see this small arrow, you have to understand that you are in user exec mode and you have very limited number of commands that are available for you. So you cannot do much in this mode. So for example, I can do show clock, which is very small command that does not have any effect on this device. But I cannot configure anything on this device. I cannot configure users, I cannot configure ports or verify anything probably. So we have to get out of this mode. So let me also show you on a router as well. So we are here. Let me get that fixed. So I'll get a router as well here. So this is a switch. I'll get a router as well. So if I get a router, that would also give me the same prompt. If I go to CLI, it's booting up. Let it boot. All right. You don't want to configure anything at this time. So you can see if it's a router, its name says it's a router, and it also has the same symbol, which means you are in user exec mode. Whether it is a switch or a router, you're always, when you log in, you're in a user exec mode. We usually want to get out of this mode because you can't do much in this mode. So the next mode is called privilege exec mode. We don't want to be in the user exec mode because we can't work much in this mode. So we want to get to the privilege exec mode, which allows access to all commands and features that are available on this device and is identified by the CLI prompt of a pound. So to get into this privilege exec mode, which is also called the enable mode, it's called enable mode as well because to get into this mode from the user exec mode, you have a command that says enable. You just type enable and hit enter. Whether it's a switch or a router, you type enable and hit enter. And you can see as soon as you hit enter, it changes the prompt. It changes the symbol. So the pound sign, this sign, which is, I usually call it a hash sign, some people call it a pound sign. This means you are in privileged exec mode, or usually people call it enable mode as well. Now you have access to all commands and features that you can run to configure this device or get into other modes from here. So remember, when you log in, you are in user exec mode. From user exec mode, you want to get out from user exec mode to get into a privilege exec mode. To do that, you just type enable and hit enter, and the symbol changes, and now you know you are in privilege exec mode or enable mode. Why do you want to get to the enable mode? Because now you have all the commands available, and from here there are other modes where you can jump into or get into those modes. So let's see what are those modes. Well, now that you are in enable mode or privilege exec mode, from here you have a command available which will take you to a global configuration mode. This is a mode which is used to access configuration options on the device. So let's say if you want to configure the IP address on a specific interface, you would want to get into the global configuration mode first. So anytime you want to configure something on this device to change its behavior, you want to get into the global configuration mode. And to get to the global configuration mode, you have a command called configure terminal. Okay, I'll do it here as well, configure terminal. Whether it's a switch or a router, this command was not available if you were in the user privilege mode. This is only available once you are in enable or privilege exec mode. And now you can hit enter, and you can see the prompt changed again. With the host name, now it says config mode. So this is when you see config in parentheses, that means you're now in the global configuration mode, and now you have access to commands in this mode which can actually change the behavior of this device. So now you are in very sensitive area of the switch or a router. You can do it same on the switch, and you get into the global configuration mode. From here on, now you can get into other modes like line configuration mode. So every time you want to configure the console port, which is the physical port on the switch and router that we saw, where you would be connecting using console cable to access these devices, you can actually configure settings on that port. For example, you can set a password on that port so that nobody can just come in with a console cable in the computer and connect to it and get access to the terminal and run commands. You want to secure that port. So if you want to secure that port, you want to get into first, you would have to get into the global configuration mode. And then from there, you would get into line configuration mode, which will be indicated by config-line. So for example, well, I don't want to show you those commands. We're getting into that in a while, okay? There's another configuration mode. So that was line is specific for configuring console and SSH or telnet configuration, which are management related stuff. These are the things you do to access the switch. For computers to communicate together, the actual data traffic, you need the interfaces like the switch has. So get that. So this switch has physical ports. There are 24 ports here where we would be connecting the computers. We actually want to configure these interfaces. You can configure IP addresses on these interfaces if it's a router. So in case of a router, so router usually have a very low number of ports, sometimes 2, sometimes 3 or 4. Switch usually have a lot of ports, and we are going to see the reasons why is that. But usually on the router interfaces, you want to configure IP addresses, and on the switch interfaces, you configure other configurations like bandwidth, speed, mode of the port. You want to shut down the interface, you want to put it in a specific VLAN, and so on and so on. So all those things you want to do usually you want to get into the interface configuration mode, which looks like this. It would say config-if. If is a short for interface, and this is how you would know from the prompt that you are now in the interface configuration mode, and whatever command you now give it to it, you will be changing the behavior of the interface of this device. Okay, so we have user exec mode. Let's get back to it here. So can do Control Z to go back, and I can also type exit to go back, and I hit enter. I'm logging into the router again. This time I can easily log into it because there is no password set on the console. So we'll have to configure the console to secure it. That comes later. So I'm in user exec mode. If I do enable, I will get into privilege exec mode. So the symbol changed, the prompt changed, and I know I'm in enabled mode or privileged exec mode. Now I want to get into the global configuration mode if I want to configure something. So I would say configure terminal, and the prompt would change. It says I am in the global configuration mode. I can configure this device now. And notice it also tells me if you want to get out of this configuration mode, you can just type Control Z. So if I do Control Z, it will take me out. I'm going back to the enable or privilege exec mode. If I want to come back here, I can just do configure terminal and I'm back in a global configuration mode. I can also get out of global configuration mode by just typing exit. And I'm back at enable mode. So I can do that. Let's go back. So from global configuration mode, I can go to line configuration mode. So to do that, I can just do line and then I say console. So line, I want to go to line console mode. I want to go to line configuration mode, but for which line? There are multiple lines through which we can access this device and manage it. Right now, we are just only talking about one method, which is the console method through which we can access this switch. So I say line space console. There could be multiple console ports. Usually there are not. So since there is only one console port usually on a router or switch, it has its number through which we identify it. So the first number for the first port is 0. So we say line console 0. This is the console which I want to configure. And I hit enter, and you can see I'm now in the line configuration mode. The prompt says it. I can get out of it. Then I can get into interface configuration mode. So I would say interface, and I have to give it the name of the interface. We'll get into that, like why I'm doing 0/0, but I just want to show you the interface mode. Oh, I'm on a router, so it has different mode. Let's do it on this. Okay, so on a switch, because the interface names on the routers are different, on a switch are different, I don't want to confuse you with that. I just wanted to show you that this is how the interface config mode looks like, and I can get out of it by just typing Control C. Okay, so we saw user exec mode, privilege exec mode, global config mode. You can actually get into your Netacad account, and there are video that explains these things, and you can watch those videos as well, how you go around. Okay, so we have seen how we get into privilege exec mode, how we can get out of it using exit. If you go to global configuration mode, we saw the line console 0 command and how to get out of it. You can just type exit or Control Z. You can also do end to get out of it as well. Okay, so you can type end or Control Z as well. All right. This is the example for the interface configuration mode, and we saw that as well. There's another video that is going through. Okay, there's another command that we did not see. So let's see. If you are, let me get out of here. So if you go to enable mode, you can also get back to the user exec mode using disable command, and you're back the prompt change. So that's another command. We've done the configure terminal that takes you to global configuration mode. With exit, you can exit out. With end, you can exit out of the mode. You can do that with Control Z on a keyboard as well. And there are a bunch of other commands. So now that you understand these basic modes inside a switch or a router, and you can go in and out of these modes, now let's see what commands we can run in these different modes. Okay, so the command that we can run on the Cisco iOS, it has a basic structure. The structure says that first thing you see here, let me get that here and get rid of this. Okay, so the first thing you see that says switch, that is the prompt. This is what we call a prompt here. So this is the prompt that you see. Well, I don't know why it's showing up so big. I don't want to use this now. So the first, the device name with this icon that shows you which mode you are in, that whole thing is called a prompt. After the prompt, you can give it a command. So this is a command. If I say show, this is a command, which is incomplete right now. Or when I do enable, that is a command. Or when I do configure terminal, that is a command. So these are all commands that I'm entering. With each command, we can just say space, and then we have other arguments or keywords or arguments. So keywords is a specific parameter defined in the operating system like IP protocol. So for example, in this case, when I'm doing configure, so the configure part is the command. And when I do space, say terminal, that is the keyword. We cannot change that. That is fixed. We always have to type configure terminal to get into the global configuration mode. But with some commands, there are some things that you can change. For example, ping is a command that most people would be familiar. So just like your computer has the ping command, the switches and routers also have the ping command. So that's the command. Then I do space, and then I have to put an IP address of some device that I want to ping. So for example, 192.168.1.1. Now this 192.168.1.1, is this a keyword or an argument? This is not a keyword. Okay, so why is it not a keyword? Because we can put any IP address here. We are free to put any type of IP address. If we were forced to use a very specific keyword or fixed word, for example, configure terminal, I cannot type anything else. I have to type terminal. So that's a keyword, that's fixed. That's part of the operating system. In this case, this is not a keyword after the command. This is an argument. Why is it an argument? Because this is a user data. I can put anything I want, any IP address. Not anything, but any IP address. So it has to be an IP address after ping, but it could be any of 4 billion IP addresses that I can put. It is not a fixed word like a command. Okay, so that becomes an argument. That's what we call argument. All right, so we have ping and trace route, which is something we will be discussing later on. Okay, the iOS help feature. So now you don't have to remember all these commands to understand like what you want to do with this device. So let me get rid of router and you'll just focus on a switch. Okay, so if you want to work with switch, let me get out of here. So I'm back at the user privilege mode. So we have two types of help feature available in Cisco iOS that is going to help us to understand what we can do with this switch, what is available to do, what commands are available. So the first one is called the context sensitive help. And basically what this is just a question mark. I just typed a question mark. I didn't even hit enter. I just typed a question mark, and it shows me that in this user exec mode where I am, the prompt shows me I'm in a user exec mode. If I type a question mark without even hitting an enter, it shows me that these are all the commands available for you to run, which includes connect, it has a disable, it has enable as well, which we used already to get into the enable mode or privilege exec mode. And it also explains what this command would do. It says turn on privileged command. You can also do the exit to get out of this mode as well, in which case essentially if you type exit at user privilege mode, it just logs you out of the device and then you have to log in back again, right? It has show command as well, which can show me a lot of different stuff. And in fact, when I do one command, I can then type question mark again. So when I do show and do a question mark, it again shows me what are the other commands available after the show, or what keywords are available after the show that I can run. I can do show up, show CDP, show clock. It is one of the commands that we have already run, and it also explains what this command would do. It would display the system clock. Show flash, it would display information about the flash file system. There's a show history, there's show interfaces. It will show me all the interfaces status in configuration on this device. So I don't have to memorize these commands. Essentially, I can just do show question mark, and I see, interfaces is a keyword, so I can type that to see interface status. Okay, so let me do show interfaces. And what after that? Well, I don't know. So let me do a question mark, and it says, well, you can do show interfaces Ethernet, you can do show interfaces fast Ethernet, gigabit Ethernet, and so on. Well, let me do show interface fast Ethernet and question mark. It says which fast Ethernet. So I would say, let's say 0 question mark. It says you can type in slash now. I say slash question mark, and it says any number from 0 to 24. You can put that here. Which interface I want to see. So I would say just 1. And I do question mark, and it still says that's it. So I do space in question mark, and now finally I see this cartridge return. So I saw it here as well. So I could, whenever you see a cartridge return CR, it means that you can hit enter. The command is complete at this point. So let me not go that far. So if I do show question mark, and you can see if I hit space to go below the page, there is no CR option after the show, which means I cannot hit enter after show because the command is not complete. If I do enter, it will say it is an incomplete command. And how do I know that? If I do a question mark, I don't see CR, cartridge return option. So I cannot hit enter. So if I go to show interfaces and I do question mark, it says you can type other keywords to get more information, or you can hit enter right now, which means now I can hit enter, and that would be a complete command and it would give me an output. So I can hit enter, and now it gives me bunch of information about fast Ethernet 01, its status, and so on, its MAC address, what is configured on it, what is the bandwidth of that interface, delay, reliability, and so on. And I can keep hitting space to keep going through each interface. Now we are at fast Ethernet 02, fast Ethernet 03, and so on. I don't want to go through all of these interfaces, so I can just type Q for quitting out of this, and it's done. Okay, there is other type of help as well, which checks the command syntax. It verifies if your command was correct at what point. So for example, if I do show interfaces and I say, let's say I do something wrong. So let's say 1, 2, 3, 4, 5, and I hit enter. This is the syntax check. It tells me exactly where I went wrong. It's telling me that show interfaces was fine, but after the interfaces, what is this 1? This is exactly where the Cisco IOS got confused. Like, this is not something it was expecting. So it is telling you invalid input detected at this marker. So check this place. So this is telling me that show interfaces is at least correct. After that, I need to see with a question mark, what can I put in? And you can see I cannot put numbers here. There's no option to do that. So that's why it told me this is wrong. This is how I keep learning these commands, okay? All right, so there's a video on your Netacad account as well. You can watch that video as well. There are some shortcuts that you can see. Okay, let's get into the shortcuts. So now we know how to find the commands, what we want to do. How can we do it very quickly? Okay. So we saw if I do enable is a full command. What I can do quickly, instead of typing enable, I can just type en and hit enter. It still works. Okay, I don't have to type in enable completely. Why does that work? Let me get out of here. It works because in this mode, user mode, if I do a question mark, there is only one command that starts with en. So if I type en and hit enter, the iOS will auto-complete this, and it knows that this is the only command that is possible that starts from en. If there was any confusion, then it would not complete it. For example, if I just type E and hit enter, then it says it's ambiguous command because there are multiple commands that starts from E. So it could be enable, it could be exit. It doesn't know what you mean by E. But if I do en, Now it knows there is no other command available, so it can run enable. Similarly, if I do EX, it knows I want to run exit because there's no other command that starts with EX. So if I hit enter, it exits out. Okay, so that's one shortcut. Now you can also just hit enter or hit tab and it will auto complete it without entering the command. So if I type EN again and then I hit tab, it will complete the command. If I type EX, it will just hit tab, it will complete the command. So now let's do it with a bit of longer command. So I do enable and I want to go to global configuration mode. So instead of going to global configuration mode and typing configure terminal, which takes me to global configuration mode, I can just say CON, hit a tab, and it's not completing it. Well, that's your problem, why it's not completing it. Because there could be another command that also starts with CON. So let's check it out. Question mark, and there it is. So CON could mean configure, CON could mean connect. Which one is it? The computer doesn't know, or the iOS doesn't know. So we have to type CONF to distinguish it from the other command, and then we can hit tab so that the computer or the machine can fill the rest of the words. After that, I can just type D and hit enter. And it takes me to the global configuration mode because T is for terminal and there is no ambiguity in there. I can get out of here. So usually you would see network engineers doing CON T, CON space T, and they are in the, CONF P and get into global configuration mode. Control Z, get out. CONF T and Control Z. This is how you get into global configuration mode and get out of it. Okay. All right. So those are the things. So with tab, you can just complete partial commands name entry. With backspace, obviously everyone knows that. You can just delete the command and left and right arrow. You can use the up arrow to get to the history of commands. If you've worked with Linux, it works just like Linux. If you hit up arrow, it shows you the history of commands that you have run. So you can go around them and run them again. So this is the history of commands that I have, and I can go around it. Okay. We saw space and enter key. Control C would cancel out from any configuration mode and ends it. We did Control Z. Control Shift 6 is something that you need to know because sometimes there are some commands that you run and it will get stuck. The iOS usually starts looking for some commands in the external database. When it doesn't find a command that you enter, and it thinks like this command might be somewhere else, not in locally. So it tries to resolve that using a DNS and it gets stuck. So let me try that and see if I can make it stuck. Let's say, I don't know what would make it stuck. I did not think of that. Let me see. So if I do conf, what can I do that wouldn't? This is incomplete command. Well, we will get into that and then I'll show you when it gets stuck. So we went through this. Okay, so let's go to your Netacad accounts. Okay, add weird IP. Yes, thank you for that. So now it's trying to translate this 12123, this weird IP, and it's trying to resolve that in contacting a domain server. And notice now that it is stuck. It will take its time. It usually takes a minute or two to get out of this because it's trying to translate this, but there is no internet. There is no way to translate it, and it will keep there. Even if I hit enter or type anything, it is not. I'm trying to do that. It's not doing anything. It is stuck for a while. Then you have to just wait it out to get out of it. It usually takes 2 minutes or maybe 5 minutes. That's where your Control Shift 6 helps. It is all-purpose break sequence used to abort DNS lookups in trace routes and things, etc. So to get out of this, I have to type Control Shift and 6, and it cancels out. Okay, do it again. So if it's stuck like this, when you give it a wrong IP in these commands, tries to translate it, and it will take a lot of time, and you can't do anything. You do Control-Shift-6. Okay. So let's go to your Netacad account. Let me log in here and click here to log in. So you have to pay attention here, because I'm doing this for the first time, because everyone is because I'm taking you from the scratch. I won't be doing that like this in every class. By this I mean I won't be showing you exactly how to get into the Netacad, how to download Packet Tracer, how to do your own practice, because I'm doing all the practice. You're not doing it, right? But after each class, you have a full week, right? After each weekend, you have a full weekdays where you have to follow these things and practice it. So right now we are in module 2. So if you go to module 2, go through these things that I'm teaching you. That's all in there. Okay. This is the operating system that we talked about. And some people are asking me for the PDF files or the presentation. And the reason for that I don't give it to you, because I want you to go into your Netacad account and study from there. Don't study from the PowerPoint or PDF files. That's why I'm not giving you those things. Okay. And the reason you have to study it from here is, like, obviously it has more data than slides. And on top of that, there are check your understanding questions after each subsection. So you studied Cisco iOS Access. Okay, give this quick question to see where you are at. Do you really understand it? And then go to the next subsection. And in this next subsection, there's another check your understanding iOS. Quick 4 questions before you move on to the command structure. Okay. So, and similarly, there are packet tracers. So there is a packet tracer file to navigate the iOS. There is a packet tracer file to navigate using terminal client or console connectivity. Okay. So I will do this one to navigate the iOS. So where is that? So if you click on it, it will download the packet tracer. And from previous class, I already showed you how to install the packet tracer. If you have already installed the packet tracer, just click on it, this lab, it open up, click on it, it will open up in the packet tracer itself. It's a pre-built packet tracer lab with instructions for you to start working on it. So click on dock here. Something is opened up. Let me cancel this. I'll dock it here, and then you can start working on it. So it has all the instructions to start working on it. So it is just giving you a practice to navigate the iOS, which we have already done. So I'm not going to do it, but you have to do it, because it is going through all the things that we just did, except for a few things that we haven't done. So let's get into that. So for example, it has step 1. It says connect PC1 to switch 1 using a console cable. This is how you would be doing in your real world. So this is a real world situation. You have a switch, you have a computer. How do you access this switch? Well, let's go to physical mode. Maybe that makes it easier. So you have a switch. So I'll just bring it a little bit here so that we can see it easily here. And we have a computer. So if you don't know what to do, there are the instructions telling you. It says click connections icon, the one that looks like a lightning bolt, which is here. This is the connection icon. And then it says select the light blue console cable. This is the light blue console cable out of these cables. This is the light blue one, first one. I clicked on it, and now I have this little cable icon. Click PC1. Okay. A window displays an option for an RS232 connection. Connect the cable to RS232 port. Okay, so let's see, where is this? Is it? Here is the computer. Here is the RS232 port. I click on this, and then I have to connect it to the switch 1. Drag the other end of the console connection to S1. You can just drag it, or just click once here and click again here. It's the same thing. And select the console port to complete the connection. Well, I don't see a console port. If I hover over it, it's fast Ethernet 01 up to fast Ethernet 0x24, fast gigabit Ethernet 01, gigabit Ethernet. Where is the console port? If you don't find it, it's usually at the back side of the switch, okay? So let me zoom in a bit again, and I would right click here, inspect the rear, and it says here is the console port, okay? And now I can click on that and it automatically connected to it. And if you go back to the logical window, it says you have connected to console port. Let me delete that and do it again. So here's the delete button. I'll delete it. You can just do it directly here as well. You go to the bolt icon. Here is the light blue cable. It also shows at the bottom which type of cable you're hovering on. It says console here, small text. So I click on it. I click on PC1. It says RS232. I select and I go to S1, click on it, and I have all the ports where I want to connect to it. I just want to connect to the console. So in logical view, it's easier to do that, but you have to practice the physical view so that you know this is how in real world you would be doing it. Okay, this is giving you a simulation of a real world. This is how in real world, this is how the switch looks like. The console port is on the back side, so you'd have to look at the rear side and connect the console port there. And this is exactly light blue console cable looks exactly like this. It has this light blue specific color so that you can easily identify that this is the console cable. All right, so let's keep going on this. And then it says, okay, once you have done that, what you need to do on the computer to access this. So if in real life I did this, so I connected these cables from computer to the switch, then I have to go inside my computer to any desktop application and I have to open up this terminal application. Okay, in real world, what would be that? It would be PuTTY. So go to PuTTY and then you say serial interface. Remember, now when you do serial interface, it automatically selects a name COM1. When you connect these devices, a console port to a computer, usually it also, these days you can connect it to a USB port as well. So usually now you don't have RS232 ports. In computer, in modern computer, you just have a USB console cable. It is still in your packet tracer, it doesn't show the names. How can I turn it on? So probably you'd have to look into this view toolbars, or maybe, no, sorry, go to options and preferences. And there are a lot of options that you might have just disabled. So for the labels to show up, it can play sounds, it can show device names and labels, logical view, always show port labels in logical view, etc. So look around what is disabled here. So I don't want to spend time here, but that's where you would be looking at. Okay, so back to our question. So we are on PuTTY, and when you have a USB console cable connected to your PC, so in fact we can just do it here as well. Well, this is we will do it in another case. So what you would have to do is you would first have to go to device manager. Whenever you connect something using a USB port, because you don't have RS232 ports in laptops, so you would buy a USB console cable and connect through that to switch 1 into the console port. And then you would have to come here inside the USB ports. It says ports, COM, and LPT. That's where you would see, by removing and inserting the USB cable again, it would get removed from here and pop up again. That's where it would show you which COM port it is connected to. So in this case, I have a Bluetooth mouse connected to it, a Bluetooth keyboard connected to it. So it shows me that everyone is connecting to the USB port, but what is the name of that port, a virtual port? So it has names like COM1, COM2, COM3. That's how you would know which COM you need to put in the PuTTY. So this is how you would find what COM port for that console port is. And then when you go to PuTTY, you would select serial, and then you would put that COM3, let's say it was COM3, and usually 9600 speed is the default. It works with most of devices, but some devices might not work. Then you'd have to research yourself, like this particular Cisco model or other vendor model. If it's not working with 9600 speed, what is it? So you'd have to study its worksheet, a data sheet, and that's where you would get this information from. But usually it would work, and then you click open, and it will open the terminal to that device. So in Packet Tracer, you would go to terminal, you have the same settings, 9600 speed, and click OK. and it opens a terminal and you get access to switch 1. So in real world, you would have to access this switch terminal from the PC. Similarly, if you look at the physical devices, you would have to get, so once you are connected, you would click on the computer, go to the terminal, open up the putty, select the COM port and click OK. And now from your computer, you're sitting on your computer connected with console cable, and now you can configure the switch. Okay. And then we have done all these things. You can follow these commands. So this is giving you the context help, the question mark, what is the privilege mode, what is the EXEC mode, how you use tabs, how you get to the terminal, how do you get out of it. You can do the show clock, how do incomplete commands look like, and so forth and so forth. Okay, you can set the clock, clear it up. There are a bunch of commands that you can do. And once you fully go through these instructions, you have this check results here that will show you that you have successfully completed the packet tracer lab here. This is just for you, so that you know you have completed all the tasks in this specific lab. In this lab, because this is a very beginner's lab, there's nothing much, so it's just showing you congratulations anyway, because we just connected the network, so it was just one task which we successfully did, so that's why it's saying congratulations. But you would see as we further go, there would be labs which would have a bunch of like 10, 20 or 30 items that you need to complete, and when you come and check your results, it will show you how much you have completed, what mistakes you have done, and go back and fix them. Okay, so this is how we are going to proceed in progress with all the labs that we have in Packet Tracer. So I will not be doing all the labs in my lectures because I have to cover the course as well. So this is the beginner's lab, so that's why I'm showing you step by step how we do it. So today, tomorrow, or you have the whole week after tomorrow's class, you have to practice on these labs. Get into your Netacad account, go through these small quizzes, download Packet Tracer, open up the lab, and start going through these instructions and start learning these physical topology, logical topology, drag and drop these different laptops, switches, routers, keep going between logical and physical, and see that when things in logical are very easy, but go to physical mode and try to understand whatever you are doing in logical, how would it look like in a physical real world inside the data center. Okay, you can practice different things. It doesn't necessarily have to be mentioned in the instructions. For example, instead of getting a PC, you can get a laptop here, and I want to connect this to the laptop. So let me delete this cable, and now I want to connect it to the laptop. I can do that. I can get a router instead of a switch. I'll get a router here, and if I inspect the rear, and you can see there is a console cable with a small USB port. So this is a modern device now. So instead of doing RS-232, I need a cable that is USB cable. So this is a USB cable here. So this is how usually you would do in the real world. So I come here to this laptop, because the laptop your laptop wouldn't probably have RS-232. So you would need to buy a USB console cable specifically, which will also be you can buy it from any computer shop. Okay, which will also be in a light blue color. Okay, that's how you know this is console cable. It's a special cable. So you put a USB cable here, and you go to router, inspect the rear, and here is the USB console. Here is the USB console. It's a mini USB port on the router, and I connect to it. And I'm connected through USB port. So you can do that. So get into this Packet Tracer labs and start exploring it. Okay, I'm going to close this lab and move ahead. Okay, so what else? We did this Packet Tracer lab. We already navigated through iOS, and we have done those things. We already connected using the physical mode, so I've already done that, but there's a lab to do it. So let me quickly download it and show you. Okay, so I just downloaded it and click on it. It will open up another Packet Tracer. Let me just close this one. No. Okay, let's close this one and open this again. And you can see when you download these labs and open them up, they're pre-built for you. So in this case, there are a lot of devices on the shelf already. You're in a physical mode. And notice if I want to go to logical mode, it says that is locked. So in these labs, a lot of things are locked so that you are focused specifically on what you need to do in this lab, and you just follow these instructions. So the instruction says that you have part 1, access Cisco switch through the serial console port, display and configure basic device setting, access a Cisco router using mini USB console cable. And there's a background scenario, go through it. So let's go through it, like install and navigate 2960 switch. So we have a shelf, we have a 2960 switch somewhere, and it has labels. So here it is in 2960 switch. I'll put it in a rack, okay? Because it says to put it in a rack. And then inspect the front. So we can inspect the front, zoom in on it, and I see it's a 24 port switch, okay? And it just tells you to do things that I've already done, so you can go through it. Now we want to say, like, if you go to rear and inspect it, we can notice it has a console port. We have done these things, so I'm going through it very quickly because we have already gone through these things. Now he says to put the PC. Well, bring in the PC and now connect it using RS-232. So I already know how to do that, and I've shown you. So where is my... Okay, so you see on the bottom, I don't have those icons anymore. That is very specific to this lab because this lab locked out all those things, and it wants me to follow these instructions. And it's telling me to get to the cable, it's not over here, it's over here. So pick it somewhere from here. So this is the, I can look at the color and see that this is the cable, and this is RS-232. And I inspect rear and connect with console cable. And if I go to check results, assessment item, you see, it tells me that I have completed this task. I'm connected to RS-232 with the correct type of cable. The physical location of the switch is correct because I dragged it on the rack and its power is switched on. The PC physical location is also correct because I dragged it and put it on the table, but it's not yet powered on, so that is crossed. So that one thing is incorrect. This is how I know how far I have done my lab. Okay, so I'll close this and I can zoom in on this PC. Like, why is it switched off? Well, it has a button which I click and it shows an indicator that I switched on. If I go to check results, assessment items, now it says powered is on. So let's continue going through our instructions. So that's done. Now it says configure the packet tracer terminal program to establish console session with the switch. Okay, so you can go to the computer, desktop, terminal. Okay, and we have established a connection with the switch. So that's done. Part 1 is done. Part 2, display and configure basic device settings. Okay, so with terminal, I would say, and notice maybe they have locked it out from me. If I click on a switch, there is no CLI tab. So I cannot configure, I cannot cheat in these labs. If it says go to the computer, connect it via console cable, and access it using a terminal, then that's what you need to do. You cannot cheat it. Like, okay, if the next steps are to configure this device, I can just go click on it and go to the CLI tab. Well, they locked it out. You cannot go there. Because in real world, this is how you would have to do it. You'd have to go to your computer, your terminal software, PuTTY, and connect and establish a connection from there. And then it says go show version and see what version it's running. Well, this is the version. Version is 12.2. It's saying exactly this. So Cisco iOS has different version. This is very old version. Okay, that's fine. What else we can do? We can do show clock. It's asking me to do that, and I've done that. And these are the things that we have done. I don't want to go through it. You can set the clock. So this is for your practice. You have all the instructions. Just set the clock and see if you can do, and then show clock again and verify that you have made changes. If I go to check result, are they testing me on that? They're not even testing me in here for that setting. So I can cheat a little bit and get away with that. But you don't need to cheat, okay? You need to learn these things. Okay, what about part 3? Access a Cisco router using a mini USB console cable. Okay, so now we get to the router. And now it's saying like, which router? 4321. So we pick 4321, which is here, put it on a rack here somewhere, and it says, okay, I've done that, inspect the front and zoom in, and you can see a console, it says console, and it has a USB port. It has two console ports. One is the regular RJ45 port, and another is a mini USB port. So if you have both types of cable, whichever cable you are available, you can use that. But before that, you can see there's an on and off button. I don't know if it's saying an instruction, but definitely we need to switch it on. So I'll switch it on. So switched on the router. Usually switches don't have on and off button, but routers have it. Okay, I'll close this. Now it says you need a laptop. Where's the laptop here? Okay, here it is. So whenever you have a laptop, usually you don't have RS-232 ports, so that's why you need a mini USB cable. So here's the cable. I'll take it from here, connect it to the USB 0, come to the router, right click, and inspect front, and then select the, well, in this case, it's not, where is the mini USB? Here it is, the USB console, and I click on it, and I'm connected. If I go to check results, it says 4321 router, physical location is correct, power is correct, physical location of laptop is correct, but it's not powered on. Okay, so if we zoom in on the laptop a bit, you can see it has an on and off button. Here it is. Now it's switched on. Okay, let's see if our check results. Oh, right here it says completion 100%. If you can see it here. And if you go to check results, you can see everything is done now. Okay, our score is 100% here. 10 out of 10, 10 out of 10, everything is correct. And we can get out of here. So we completed step 3, and step 4 is just go through desktop, terminal, and access the router. And we just access it. That's it. It says, because after the router boots, it says, do you want to enter the initial configuration through a wizard-like dialog? Usually we just say no, because we know how to do that using command line. And that's it. So this is how you complete your packet tracer lab. So this lab is 100% complete now, and we can move ahead in yours. So that's why I'm not giving you those slides and everything. So you have to go through here. So now you know basic things. I want to give you like a 5-minute break, and then we move ahead. We just have like 10 or 15 minutes session left out. Okay, I'll give you, let's take 10 minutes break and we'll come back. Okay, so take a breather, take a fresher, get your thoughts around, and then we'll start again. Okay. All right, let's get back to it. So for those who are, some people I've seen in the chat who's saying like this is going too fast for them. Here's the thing. I'm not going too fast, but I'm not going too slow either. The thing is that if it's too fast for you, that's not a problem, because I'm not assuming that I'm just showing you this and you got it all. That's fine. We're going through everything in module 2 so that we have a high level idea, so you know what's coming next, right? This is something we are going to work on today, and then for tomorrow we are going to forget about packet tracer. We start going through the theory, and there's a lot of theory that we need to cover, and then we will keep coming back to these things. And all the configuration that you see that we're doing today, this is something you would have to do it again and again your whole life, right? So we're going to do this a lot. So you will have you will have to create a muscle memory and practice this a lot, and you have to do it yourself. And I will keep coming back to this and do it again and again. This is not one time thing that I've done this and I'm gonna say, hey, we are not going to see this again in our entire course. No, it's not like that. You will keep coming back to these things. That's why these are called basic device configuration, basic access, basic navigation, because these are the things you will be seeing whole day. You'll be seeing me doing it whole day. You will be doing it the whole day. So this will be your second nature. So don't worry about it. It becomes very easy. You just haven't practiced it. You're just seeing it for the first time. That's why it looked like this. So this is something we're going to repeat a lot. Okay. So now we haven't yet configured anything. We just saw how to navigate the operating system, how to access it, how to give it commands, what are the different modes, how do we get into one mode, how we get out of the other mode, and why we get in and out of there. We haven't yet configured anything, okay? So now we get into the actual basic configuration that you bought a switch, or you have a job and your boss gave you a switch that, hey, we bought a new switch, a new router. It's in the box, just get it out of the box and let's start configuring it. So now we are just at that part yet. We're just taking it out of the box, and we just learned when you take it out of the box, you need a computer or a laptop, and you need a console cable. If you don't have it, you tell your boss that we need a console cable to access this thing. You cannot access it without it. And you buy it from any computer shop. And when you're buying it, you tell the computer shop guy that you need a USB console cable, because these days we don't have the RS-232. You won't be able to even buy the RS-232 type of console cable these days. So they would just have that USB console cable, and they would give it you and connect your computer and to the switch console port, and then you install PuTTY. It's a free software. Just search and download PuTTY and go to your device manager, find out where is that port connected to, COM1, COM2, COM3, just like I showed you in device manager. And then inside PuTTY, you put that, okay? And that's how you get to the terminal access. Once you get the terminal access, now you are starting the basic device configuration, starting from the device name. What would be the name of this device? Because we saw it was just saying switch. Well, that's not a good name. We might have 5 switches. All of the switches are saying they are switch. Well, we just need to start giving it a more meaningful name. And that's when you can get into the configure terminal, because now you're changing. You want to change something. You want to change the name of the device. Go to the configure terminal, global config mode. You get into the global config mode and you say host name, that is a command, and space. Give it whatever name you like. It can have numbers, alphabets, but it cannot have spaces. It can give dashes. So what would you call this? Is this a keyword or argument? Can you put that in the chat? What would be this? Yes, this would be an argument. It's not a keyword, because a keyword is a fixed word in the iOS. This is not a fixed word. You can give it in any name, so this is an argument. So host name is the command, and the name that you give it is an argument. And you hit enter, it will instantly change the name. That's it. You just change the name of the device. And then the next thing is passwords. Well, just like you bought a console cable and connected to the switch, anyone who can physically enter the data center, he can just have a console cable and a laptop, and he can connect to it and start making changes to your switch. Well, we don't want somebody to do that to our switches and routers, right? So we want to secure our devices. So the next thing is to put in a password, and password has some guidelines that you have to have a strong password and so forth. So that's a common sense. So we go through that. Now we see, how do you configure a password? Well, I already talked about that. In order to secure your console port is a physical port. Anytime you want to make changes to that console port, like for example, putting a password on that console port, that's so that when people connect their console cable to it and go to PuTTY and hit enter, they don't just get inside, they don't just get connected to the switch and start giving commands. It will ask, the console port will ask for a password. Do you have a password? Otherwise you cannot enter. Okay, I'll get into the full screen. Right? So to make changes to the console port, you have to go to the line console mode. To get into the line console mode, first you go to the global configuration mode, then you say line console, because you have just one console port. Usually you say 0. 0 is the number of the port. So it's usually always line console 0. You get into the line console mode and you say password space, password is the command, and you say space the argument, the password that you give. So in this example, it's a very easy password for practice, but in real life, you would give it like a secure password, which is complicated with alphanumerics, uppercase, lowercase, etc. After that, you say login. So setting a password is different than checking. So with this command, you just set a password on the console port. It doesn't mean that when somebody connects to it, the console will check the password. So in order to enforce this password now that you have set, you would say login. So when you say login keyword, now you enforce password checking on the console. Now when somebody connects to this port, the router or the switch will say, give me a password, otherwise you cannot get the terminal access. So this command is, or just Control Z out of it. Okay, so let's look at that. So in this case, I have already downloaded this packet tracer lab, which says configure initial switch settings. So I've already downloaded it. You have it in your Netacad account, and let's follow it. So these are the things that are already covered in here. So just go back here, and let's see. So we'll click on the switch 1, go to the CLI, and you can see that we can just do, we're already logged in. You can do enable, you go to the enable config mode, and we can see that from the prompt. Well, I don't want to get through that. We'll come back to that because it will be a bit confusing for you right now. So we'll create a basic switch configuration. So things we already know. So to change the name of this switch, you'll have to go to the global configuration mode using config T or configure terminal. Hit enter. Now we are in the global configuration mode. Now we say host name space. In this case, the instruction says what should be the name of the switch. Let's say it says S1 because that was the label. So we change the switch name. It's that easy. But you have to be in the global config mode. Now we want to secure it. So this is the first thing we want to do when we get a brand new switch. You want to change the name so that you identified which switch this is, and then you want to secure it because you just access it. You don't want other people to access it exactly like you did. So you want, the first thing you want to do is give it a name and put a password on it. So for that, you would, which port you use to connect to it? Console port. So that means you need to put a password on the console port. To get into the line console mode, to do that, you have to be in the global configuration mode where I am. And then I do line. There are multiple lines. We want to configure only the console line. If you do a question mark, you can see you have another line also, which is called VTI, virtual terminal. That's the one when we configure SSH and Telnet, we will be configuring this line because that's another way to log into the devices, to access the devices and configure them. Right now, we are only focusing on this console method where you physically connect to the physical port, console port. So we say line console 0. And we are now in the line console, line configuration mode. And then we say, or you can do a question mark and see what are the things you can configure on this console port. There are a lot of different things. We are interested in putting a password. So set a password, do a question mark. It says just specify a hidden password. You can do a 7 as well, or just do unencrypted clear text line password. So for simplicity, you'll just hit enter. I'll just say clear text password. In this case, it's let me in is the password. I hit enter. Now, this is where a lot of people make a mistake. They will hit enter and they think they have configured a password on a line console, which is true. You have configured the password, but you haven't configured checking on this port. So when somebody connects to it, although there's a password, but nobody is checking it. I cannot go full screen on this one, but I can change the from option and preferences. Can change the font for the CLI so that you can see it better. Is this a CLI? I think so. Yep. Okay. So if you do question mark, you see there's a command said login. It says enable password checking. You set a password like this and then you enable checking. Okay, so you say you say login. That's it in Control Z. So you have now configured a password on line console. What are the commands we did? We went to the global configuration mode. We said line console 0. Then we said password Cisco or let me in. And then we said login. These are the commands that you need to put to do that. And you have that already in your instructions. Okay, so that's available for you. So now we have to verify whether when we connect back to it, whether it would ask for a password. So I'll do exit to log out from this device completely. And you see, as soon as I hit enter, it says, no, can't get without password, can't get in. So I press enter. I'm connected to a console using this computer. Now, anybody who consoles into this device physically, they would have to put in a password. Let me in, and now I got the user privilege mode. Okay, but notice that if I use do write without login, is that okay as well? I don't know what you mean by that question. Can you rephrase your question? Okay, until you do that. So notice that I have a password on a console port, but once I do have that password, once I get into the user privilege mode, I can get to the enable mode right away. So sometimes we want to give a password to someone like an internee, someone new starting out. We want to give them the console password so that he can log into the device and do some show commands. So for example, you're an internee and I give you a password, so you use the console cable and I give you a password, so you come here, you connect to it, you enter the password, let me in, and you are in the user privilege mode, and I don't want you to be able to get out of this user privilege mode. Because you are an internee, I just want you to have these commands available, which are very easy. You can do show clock to see the clock. You can do ping 192.168.1.1 to do some small testing. You can do trace route for some testing, telnet, SSH, do some show commands like show running configs, maybe even not that, show users, show IP, show flash memory, and so on. Okay, so I want you to have these commands available. But if you go and you are an internee, you haven't yet learned what to do with these devices, I don't want you to be able to get into the enable mode or privilege exec mode, because once you give the enable command and you get this prompt changed, now there are a lot of commands available for you. If you configure them and you don't know what these commands, you're going to destroy my device. You're going to destroy the configuration. You are disconnect a lot of users, right? So I don't want to take this risk. So what I can do is that I can put another password on the enable mode. So when somebody that logged in using the console with a password, if he wants to get into the enable mode, he needs to give another password. So to configure an enable mode password, again, you go to config T, global configuration mode, and then you say enable secret, and in this case I'm saying class in here. This will become the password. Secret is the keyword, class is the actual argument where you give the password. Okay, so in these instructions it says to put the password Cisco with C1S, or it's a $sign C and a 0. So that becomes enable secret password, and it's set. Now if I get out of here and I give the password for the console, which is let me in, to the internee, he can log in here, he can do some show commands, do some ping test. But if he says he wants to get into the enable mode, where it is very risky for him to go there, because I don't want him to configure anything on this device, I just want him to do some tests and do some show commands, he would need to give another password, which is different from the console password. It's not let me in, it is now Cisco. So C1 $C0. Wow, C1 $sign C0. Okay, so that's how you secure the enable mode. And then we also have the other line VTYs which we want to secure as well. So there are other ways to get into this device using SSH and Telnet. If you don't understand that, that's fine. We will be doing that again. But you have to remember that you have to secure those line VTYs, which are from 0 to 15. So console was line console 0, but line VTYs are many because these are virtual lines, not a physical console port. And there are 16 ports, so there are 0 space 15. So we are saying that we want to configure all the line VTYs, which are from 0 to 15. Hit enter. Again, I'm in line configuration mode, but this time for the VTY, not for the console. And the commands are exactly the same as it was for the console. So you just say, it's not showing here, but we can do it. So we can do password, let's say, let me in, and log in. Exactly the same way that we did for line console. Okay. So that's that. So you have secured the enable mode, you have secured the line console, you have secured the line VTY as well. But here's the problem a little bit. So everything whenever you run a command on these devices, it immediately takes effect. When you hit enter, that change is made. There's no wait time. Okay. So now everything that I'm doing, it has to be saved somewhere, right? So every time I'm doing right now, it is happening in the RAM. RAM is where the operating system is running, all the commands are being run, they are being saved in the RAM. But the problem with the RAM is if you lose power, for example, if the switch was rebooted or if it lost power and you switched it on back again, all the configuration that you have done would have been lost. Okay, so everything you're typing right now, you can see it is being saved in a very specific file called a running configuration file. So we can see that file if you just do show running config, show space running dash config, hit enter, and it shows you where it is. This is where we put the command show running config. It says it's building the configuration. The current configuration is this size. This is the version 15.0 of iOS. And these are all the commands that we have configured. Hostname S1, this is the command we entered. That command actually went into running configuration file and got saved. Okay. There are other commands. There are some commands that are by default in there. Some are the one that we changed. We also went into the global configuration mode and we said enable secret, and then we gave a password. Since we said a secret, not a password keyword, that's why it is encrypted for security. So it's saved in the running configuration file, but you cannot read what exactly the password was. Okay, I keep hitting space to look at the full file. It has these interfaces that it's showing me, which has nothing configured. But then there is line console 0 that we configured. That settings that we did, the commands we ran, it is saved in this running config. We went into line console 0 and we set up this password let me in. Since we used a simple password, what does the 5 mean? Where is the this one or in here? This means the encryption method that it's been used. So 5 is also a bit weaker method to encrypt. It can be reversed, but it's better than the plain text. So this is the encryption method used to encrypt the Cisco password that we put in, and it converted and encrypted into this string. 5 is just showing me which type of encryption it used. There's another type, which is 7, which is even a weaker one. In here, no encryption has been used, so you can see the password that we set on line console and also on the line VTY from 0 to 15. Sometimes it breaks the commands that we enter into 2 different sections, like in this one. We configured line VTY from 0 to 15 all at once, but it separates and shows it in different, but both have the same configuration. Yes, you can decipher it if you have with certain knowledge, and there are different tools. It's very easy to decrypt this back. That's why it's not safe, and that's where we are getting at. If somebody gets this encryption, it is very easy. Just search online for Cisco encrypted password for enable, and you put that in, and it will just decrypt it right away for you. It's very easy. Okay, so this is where everything has been saved, but this is all in random access memory, in RAM. If you lose power or reload the switch, you will lose all this configuration, and when you power it on back again, it would have changed everything. It will named switch again. You will lose this, all the configuration that you have done. Okay. But anyway, coming back to our encryption. So when we do show running config, we saw that we can see this encrypted, which is weakly encrypted. We can also see these passwords. We want to encrypt it further. We don't want somebody to do show running config or get this file to see this password. So we have to go to global configuration mode again, and we just say service password encryption. So I'm in global configuration mode. This service password encryption. Hit enter, nothing happens, but now it has encrypted the whole file. If I do show running config, you can see this is already encrypted, but we keep hitting space. Now you can see that now the passwords that we previously saw, that those are being encrypted with type 7 type 7 algorithm, and this is like a weak type of algorithm. It can also be reversed, but it's better than clear text. So now you cannot see those passwords, which was let me in clear text, at least. That those are being converted. Yes, VTYs just mean virtual terminals. So when we configure SSH and Telnet, which we will be doing quite often, you will see them in action. Okay. Another thing is that you can configure a banner. So it's just a message that you can configure, banner message of the day, MOTD, and then you give it some sort of, let me actually get rid of this. Okay. Okay. And you give it some action, and I'll say hello or welcome. Okay, I can't get rid of this. I don't know. Okay, you can say hello and welcome. Oh my God, like why I can't just get clear. Okay, thank you. Hello and welcome to CCNA class. Wow. And just do this. And we have set up a banner. So whenever somebody logs in first time for this, you'll be able to see this banner. Usually you would put a legal notices here so that somebody who is logging in, you would warn them that if you're a hacker or you got a password from somewhere, do not enter to this device. Just get rid of these notifications first. I don't know why they keep popping up. Okay, so that was let me in, and we can go to enable $1. Zero. Okay, so we've done these things. Okay, now to the configuration file. So whatever configuration that you're doing it, they are being saved in show running config, and these configurations are being saved in the running config. Here it is. So we do show running config, and that is being saved in random access memory. It reflects the current configuration, whatever is currently configured on this device, that it shows in the running config. Okay, modifying a running configuration affects the operations of the Cisco devices immediately, and we saw that whenever we type in a command, it modifies the running configuration, it gets saved in the running configuration, and it changes the behavior of the device immediately without any delay. So that's why you have to be very careful what you are configuring, what commands you are putting in. RAM is a volatile memory. It loses all of its content when the device is powered off or restart. So you are making changes, you are putting in commands, all commands are being saved in running config and changing the behavior of the device, and you are doing what you want from the device and you're good with it. You made all those changes, but there's still a problem. It is working as you expect it to work, but the problem is that everything is saved in running config, and if you restarted the device or powered off or you lost power and you restarted back again, everything would be gone as if you haven't even configured it. So that's a problem. To solve that problem, you have to save whatever you have in running configuration in another file called startup config. Okay? And the startup config is saved in a different place. It is not saved in RAM. It is saved in NVRAM. NVRAM stands for non-volatile RAM. So we are talking about the hardware inside the device. You have a RAM, which is a volatile. If it loses power, it loses all its contents. So it will lose the running config file. When it reboots again, there would be no running config. But there would be a startup config saved in non-volatile RAM, which does not lose its content when you power it off or reboot the device. So you need to save your running config in a startup config every time you make changes. So when the switch, whenever it has to reboot after losing power, it will look for startup config in the NVRAM, which contains all the commands that will be used by the device upon startup or reboot. Okay, so let's see that. So we have two files we talked about. You have running config. You can see it by doing show running config, and we saw it. It has all the commands that we entered. We can keep giving it commands, and it keeps getting saved in show running config, and we can see it in using show running config. If I do show startup config, it says it's not present. It's empty because we never saved anything. Now we need to have a startup config, because if we lost power and the switch came back from the power, it will look for startup config, and there would be no startup config, and that's why it will lose all the configuration. It will start from the zero. It's reset. To save ourselves from that, what we would do is we need to save this running config file into this startup config file. To do that, you have a command called copy. So you are copying the running config. What are you copying? You're copying running config into what? Into startup config. So that's your whole command. It's saying copy whatever is in the running configuration that we saw using show running config file command, and put it inside the startup config, which is currently not present. We tried to see it. It says it's not present. So once we copy it, then it would be present. So I hit enter. It asks for confirmation that the file name should be startup config question mark. I just hit enter, which would mean yes. So I hit enter, and it says building configuration. Okay, it's done. So now if I do show startup, which we did here, and it says it's not present, let me blow it up. So over here it says it's not present, but once we run this command, copy running config startup config, it would now say show startup config, and we hit enter. Look at that. It is showing me exactly the same commands that we saw in show running config, because we just copied everything that was in the running config into the startup config. Now we are safe. Now we would not lose these configuration if we restart this switch or we lose power and it come back again. When it boots again, it will start looking for the startup config, and now this time it will find all these commands in the startup config, and it will apply those commands on the device after reboot, and you'll have the switch exactly where you left it with all the commands and configuration. Okay. There's a video in a Netacad that you can watch on this for everything that we've done. What else? We are doing the packet tracer already. So where is my thing? So we already opened up that packet tracer. We are here, and we configured these things. We have It's a secret. I just did a different password, but you have that. Yes, yeah, you can do that, but not on old switches. That's a new command, but I don't want to confuse students here. So I'll leave that. We did show running config. We did service password encryption, encrypt the password in the running config. We configured the MOTD banner. It's just a banner that you would see when you first time log in, so that you can put anything in here. We saved the files to NVRAM by running copy running config startup config command. So now all the running config files are saved in startup configs. And you can do the same things on the switch too. I don't want to do it. This is for you because it's the same thing. And if we go to check results, I would haven't done anything because I used a different password, so it says it's wrong. I used a different secret password, so it says it's wrong. I haven't configured anything on switch 2, so everything is still missing. That's for you to do. But rest of the things, I think we have covered this lab as well. So you just have to follow these instructions. It is showing you exactly what you need to type. You just need to get familiar with it. Just practice on it. There's nothing that you can't do, okay? You just need to sit down and do it. So these are very basic labs, very easy to follow. All the commands are given here. You just have to sit down and do it, okay? Okay, so this is the final thing. I mean, it is all same lab, so we have to, whenever you're working with devices, definitely so far we're just configuring the switch so far. We are not doing anything with switch, like why did you buy a switch? What is the real purpose? What is the goal of configuring this switch? What do we want to do with the switch? Well, the real thing is that we want the switch to make two computers communicate together. That's the real goal, which we haven't seen yet, right? So let's quickly see that, like, why are we doing this? Well, in order to do that, what you have to do, let me close this lab basically. So let me get to the, so all the end devices must have IP addresses. So IP addresses are the like identification for the computers, for the end devices. This is how they communicate. This is how you tell one computer which computer you want to talk to. And that's where IP addresses come in. We're going to talk about IP addresses a lot later in the chapters. This is just to give you a high level understanding that every end device that wants to communicate on the network must have an IP address. IP addresses have two different versions, IPv4 and IPv6. Computers can either have IPv4 or IPv6 or both of them at the same time, but they need at least one IP address of any version to communicate on a network. Not just a computer, everything that needs to communicate on the internet or on a network must have an IP address, whether it's printers, voice over IP phones, security cameras, your smartphones, everything has an IP address. You cannot be on the internet or the network without IP address, okay? In our computer, we configure it like this. So if I go to my Wi-Fi and go to network and settings and bring it here, so over Ethernet, let me, this is connected, not connected, but where would I be able to do that? Windows 11 is not good. It used to be so easy. Well, let's not do it. IP config, I can see that my computer from my Wi-Fi adapter has an IPv6 address here, and it also has an IPv4 address. So every computer, every mobile phone must have one in order to communicate. And similarly, routers would have IP addresses. Switches don't have IP address, but you need to configure one in order to access it remotely via SSH and Telnet. What switches have is usually the interfaces. So these are called ports or interfaces through which you would be connecting other computers to the switch, either copper cable or fiber ports. Depending on what type of ports these switches have, you would need to have the exact same cable as well. So usually the switches come with these RJ45 ports, is what we call port, a single port, where you can connect this copper cable and you connect that to a computer as well. Okay. And this is how you would connect that. And then you would have to configure IP addresses. So we would jump right into a lab that shows us basic switch and end device configuration, which would give you the actual thing, like why are we doing all these things that we are learning and doing? This is the actual thing that we want to do. This is the reality. This is what we want to do. We want to make two computers communicate together. That's all we want to do. I cannot go to a logical topology, but here it is what it's showing a topology that you have PCA connected to a switch 1 is connected to switch 2, and PCB connected to switch 2. If you do not understand this right now, no problem. We will be going through these things again and again, okay? But this is to give you a high-level idea, like why are we doing all this? What is CCNA? This is CCNA. Now we are getting into it. This is what we want to do. Why did your boss buy a switch and gave it to you to configure it for him? This was the reason, because he has many computers in his office. He wants all the computers to connect together and communicate and share a printer, share a file, share the internet or anything. So they can do all those things. That's why you have switches. So you would connect all computers together. This is what we are doing. But in order for computer to be connected and communicate together, your computer must have IP addresses. Switches can also have IP addresses, but they don't need it. We configure IP addresses on a switches for the management purpose, so we can log into it using SSH and Telnet and access them. Okay? So if we follow these steps, so we drag switch 1 and switch 2. That's what it says, so that's what we do. We have switch 1 and switch 2 here. So you bring switch 1 here, bring switch 2 here. This is what your boss is asking you. So think about it like this is your task. You're having a job and your boss is telling you, just do this. I bought 2 switches, put them on a shelf, just bring them to the data center, put them in the rack, and now start connecting them, because we want these computers that we have to communicate. So we have a lot of cables available, so we get a copper crossover cable. So you hover over here, it says copper straight through. Well, what is this one? It says copper crossover. That's what it says. Click a copper crossover. So this one is the copper crossover. I clicked on it. Click the fast Ethernet 01 on S1. Well, this is the fast Ethernet 01 on S1. Here it is. Click here, and now connect it to switch 2 fast Ethernet 01, and it's connected. And you can manage this cable, like manage it, hide it, or show it, change the color of the cable, whatever. You can do it, okay? So it's just like a real life simulation in a data center. Then you just follow these instructions. Go to copper straight through cable, click on that, and then fast Ethernet 0 on PCA. Well, where is PCA? Well, let me first bring the PCA here, and then get a copper straight through cable, and then the instruction says to where is it? PCA fast Ethernet 0, which is here, and connect it to fast Ethernet 06 S1. Well, which is here. That's it. We're connected just the way it wants us to connect. So now your topology that is here, that PCA connects to switch 1, see, it says connect to F0 by 6. And PCB connect to F0 by 18 to switch 2. So bring it here. I'll put it on the side, not here. For some reason it doesn't want to come here, okay. And then we put another one, connect this computer to switch to F0 by 18, which is here. So now we have connected both computers to both switches, but the switches are also connected together as well. So now this topology, this is the logical topology in a diagram that you see physically. This is how things would look like. But when you put it on a diagram to talk about the architecture with other engineers to understand what is going on, you would represent this physical thing that you have in here, how things are going, like this. That's why it's called logical topology, because it's just showing you the logical connectivity, what is connected to what and how. If you look at it, things physically, it's not very easy to understand who is connected to what and how, which port, right? That's why we have these logical topology for easy understanding. Then you configure the PC, so obviously you have to switch it on, both of them, and then you go to IP configuration. So once you connect it to a switch, then you have go to desktop IP configuration. Now you have to give some IP address to this device for identification purpose. Otherwise, one computer cannot talk to another computer, even though they are connected to the same network, same switches. Okay, so PCA desktop IP configuration, and it already gave us a table like what to do with it, what IP addresses there are predefined for us in this case. So I'll just copy these and put it in here. So this should be the IP address. It's not letting me do that, so I'll just type it. And then this is the subnet mask. We are going to understand these things little by little now. Right now, we're just following instruction. So you just get familiar with following instruction on packet tracer. That is your only job from this class, okay? Default gateway is not needed, so we'll close this. And then we go to PCB, we'll do same thing, go to IP configuration. It says repeat previous steps, assign IP address from the table. Where is the table here? Okay, so PCB has an IP of 192.168.1.11 and subnet mask, and close that. So we have done that, and now if I go to command prompt from one PC, so let's say this is PCB. So on PCB, if I want to communicate and see if I can communicate with PCA, I have to have a tool called command called ping, which I have on my computer as well. If I open my computer and I can ping anything on the internet, let's say 8.8.8. 8.8.8 is the IP address of the Google DNS server on the internet. I can ping that from my computer for testing the connectivity, whether I have the internet working or not, whether my packet can go out of my computer through the internet, go around the world, reach out to the servers of the Google, which are probably in the United States, ping it, and that server would respond back to me, and this is how I would know that, hey, I can reach out to anyone in the world. So if I hit enter, it is telling me, yeah, I can communicate with it. So I sent 4 packets and I received 4 packets back from the Google server. So that's how I know I'm connected to the internet, or at least I'm connected to this computer, which is on the internet. Similarly, in your smaller network, we want to see if PCA can communicate with PCB. So you do ping and provide we are on PCB, so we provide the IP address of PCA, which is 192.168.1.10. So we'll say 192.168.1.10. And yes, just like my computer did, this computer also says that it sent 4 packets and it received 4 packets. This means when I hit ping, my PCB, the packet went from this cable through this cable out of it to switch 2. And the switch 2 has this blue cable connecting to the switch 1. The packet went through that. And then this switch 1 has this green cable connecting back to this computer, and it went inside it. And then this computer responded back through the same path. This is how switches connect multiple computers together, and they can send each other packets. Now, all these switches have, this switch has 24 ports, switch 2 has 24 ports, which means I can connect to 48 computers together using these 2 switches, and all of those 42 computers can communicate together. That is the real purpose of this networking device, which is called the switch. Okay? So now we also can configure the switches as well, but right now I will not do it. I will, because I think it's a lot for you, but I hope this gave you a very high level idea of what networking is about, how it would look like in real world how it looks like, what is the difference between logical topology, physical topology, the basic configuration, some command syntax, and how I hope it gave you a feel of what CCNA is about. That's the whole idea of this session is. Okay? Right? So we will wrap it up here today and see you tomorrow at the same time. And if it is overwhelming, don't worry about it. These are all the things we will be doing again and again, okay? But I really do hope that you go inside your Netacad account, go through this content, go through these labs, practice them, and go through those small quizzes in there. And also there's finally, when you complete the module, there's a little 14 question quiz. Do that and see where you stand. What do you understand? What you don't understand? And then put the questions in the chat so that we can communicate about it or bring the questions tomorrow in the class, okay? So if you have any questions, you can put it in the chat anytime, not necessarily right now, and we can wrap it up here, and I'll see you tomorrow, okay? Because I can already see everyone is a little tired. Okay, who's got some? Our class is always going to be this duration, so some of you can plan accordingly. Mostly, yeah, at least 2 hours every time. 2 hours is at least, yes.